Okay, so we're gonna calculate the betweenness values of the edges in a network graph. So this is an example question, okay? But then we're gonna see how to calculate the fractional value first, because the betweenness value for each edge is the sum of the fractional values across different types of the same network. Okay, I'll explain shortly. So let's say right now we are interested to see how to calculate the fractional number of shortest paths from B to the other edges. The first step, okay, is to do the breadth first search representation of the starting node to the rest of the nodes. So for example, if let's say we are interested in B, it will look something like this. Okay, it is important to write it in levels, okay, because as you can see, if we start from B going to the other nodes, the graph can get a bit messy. But if you don't write it in a structured format, it's going to be difficult for you later. So it's important to write it in levels. So what I mean by this is, we start with B first. So we have B. Actually the question has this extra part. Okay, so we start from B and we take B as a 0 level, right? Then you have level 1, level 2, and then level 3. Okay, I'll show you why there's 3 levels. So B is a 0 level, and then in level 1 we have A, C, and H. So we write it as A, C, H, A, C, and H. So this is the first level. Okay, then we just connect them first. So this is a triangle. It goes like this. It goes like this. So C and H is the connection. Okay, good. Then next we do the nodes in the second level. Okay, second level will be D and IG, right? So we have D here, D, and then I and G. I and G. This is a Is this correct? Yeah, this is triangle. Next, in the fourth level, we only have E and F, so we write that as E. F. This is a triangle, and this still is connected. Okay, so that's the first part. Okay, writing the breadth first search representation of the starting nodes. So that's how it goes. Next step is to figure out the number of shortest paths. Okay, so there's actually 2 ways to go about this, right? So next one is to I will say figure out or calculate. Okay, the reason why I say this is because there's 2 methods: number of shortest paths from starting node to all other nodes, right? So in this one, what we do is we have the first option. Okay, the first option is to figure out yourself slowly. Trace manually, or actually the second method is much easier. It is a top-down approach. Okay, so I would like to use the second method, and then we can use the first method here to verify it. So it'll look something like this. The key point to note here is that the shortest paths for the nodes in the first level is always 1, because there's no other way for you to get a shorter path than 1, right? So that's the first key point to take note of. Level 1 nodes, the shortest path is equals to 1, right? So that shows that this is 1, shortest path, 1, and 1. Right now, instead of us having to figure out manually, like I say D, or this is the fastest route versus this, whatever, a much easier way is to use this top-down approach, which is just to sum the number of parents. So actually the number of shortest paths is equal to the number of parents it has. So in this case, this would be D only has one parent, so it's just 1. And then F only has one parent here, so it's also 1. And then E has 2 parents, right? G and D, so this is 2. This only has one parent, so it's 1. This only has one parent, so it's 1. Right? So we're done with that step. So now the third step is to calculate the fractional value. So the first step, right, is I would like to call it calculating the raw value of the edge, and then the second step is calculate the fractional value. So this is actually the raw value plus the sum of the values of the children. Okay, let me show you what this means. So the first step here is to calculate the raw value. The raw value is actually very simple. It's just parent over child. So if you go to this, you can see that this is the parent, this is the child. So 1 over 1, the raw value is 1. So parent over child, this is 1 over 2, so this is 0.5. Similarly, this is also 0.5. This is 1, 1, 1, 1, 1. Okay, take note that there isn't a fractional value for nodes in the same level. So C to A, there's no fractional value. E to F, no fractional value. I to G, no fractional value. So it's always one level to the other. Okay, so now we've written down the raw scores. Here, here, here. Here one more. Here, here. Then now what we do next is we take the raw value and we add it with the total values of all the children. So E and F is already the lowest level. So that's why these 3 scores are the final values, because E and F has no children. But then G has 1 child, which is E. So therefore, this 1 has to be plus with 0.5. So actually the final value is 1.5. This is not a child because this is the same level. This guy has no children for I, so this is the correct final value. For 1 here, H has 2 children, so must add in both these values. So the final score is 3.5, right? Now we look at this guy. He has 2 children coming from here. So the final value is 1 plus 1 plus 0.5, so it's 2.5. Similarly for this, he has 1 child, which is D, so we just take 2.5. 3.5. This guy, A, has no children, so the final value is 1. Right? So if I erase everything, okay, it will look very clear. Let me erase all the shortest paths values so we can see clearly what the final fractional values are. So this is 3.5, this is 1, 3.5, this is 2.5, this is 0.5, this is 1, 1.5, 1. Okay, so those are the fractional values for this for the iteration where we keep B as a starting node. Okay, so there's a few ways for us to verify. Okay, so you can take the total number of the fractional values in between 0 and the first level. So that will be 7 plus 1, 8. Okay, so you have 8, then you calculate the number of children nodes it has. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. Or you can think about it in this way. When information flows from one node to the next, it will leave one at the next node. Alright, and then if there is a split, if there's no split, it just leaves 1. If there is a split, then you have split it accordingly. So you can see if it makes sense, right? So from B to A, there isn't any so B to A, it leaves 1 here, and 1 leaves to 1 is fine. So from B to C, 3.5 becomes 2.5, so it actually leaves 1 here, right? Then from 2.5, for C to D, it will leave 1 at D, So the result is 1.5 that is split into 0.5 and 1. So over here, B to H is 3.5. It will leave 1 at H. So the result is 2.5. And 2.5 gets split into 1 and 1.5. The 1.5 is at G. It leaves 1 at G. Then there is left with 0.5 and he only has 1 child. So it goes to E. So that is the way for you to calculate the fractional value of the tree. Then now if you want to calculate the betweenness, what you have to do is you have to repeat steps 1 to 3 for all iterations of starting node. Meaning for now, in this tree, this iteration that we're looking at here in blue has A as a starting node. This iteration has B as a starting node. So next you have to do C, D, E, F, H, I, G as a starting node, and you have to repeat this analysis, right? And then the result, what you have is you need to calculate the betweenness values. So the betweenness values, right? Betweenness is the sum of the fractional values across all iterations. So you can do this by drawing a table of H and starting node. Okay, and then the elements in this table are the different fractional values. So for example, we have H, let's say A, B, A, C, right? So we have A, B, A, C, A, B, A, B, A, C, B, C, B, H. Okay, let's write those. B, C, B, H. Right? And then we have different starting nodes. So we have A, B, C, D, all the way, right? All the way. So what happens here is we write down the different values that we have here into this column, because this is the B starting, right? And then once you repeat this analysis for all the different nodes, starting nodes, then you have all the values here. Then the resulting value, okay, this is the final value. This is the betweenness value, okay? It's the sum of the values in the entire row. So yeah, that's how you calculate betweenness.